So I'm Bartosz Szulc, you can call me Bart, and I'm basically going to talk about my journey, my research that I did regarding test coverage. And yeah, it's going to be a risk-driven code coverage analysis, basically. So if you are on Twitter, this is my Twitter handle. You can follow me on Twitter. If you have any questions and we won't find time to answer them, I won't find time to answer them. You can always write me an email. Those are my email addresses. So yeah, the question that I want to answer in this presentation is how good are our tests? Like if you have automated tests, maybe there are times when you question the value of those automated tests, when you question the quality of the automated tests. So I'm not from here, I'm from Gdańsk. And I already spent a lot of time preparing the presentation with those technical problems, so I'm not going to go into details, but Gdańsk is in Poland, right? So we are here. What I do is I help deliver Jira. So if you use Jira, especially Jira Cloud, I work on that product. I'm also organizing a conference called Agile and Automation Days. So if you are in Krakow in October next year, probably there will be Agile and Automation Days conference. And I also, in my daily job, teach developers how to test and how to be better quality engineers. And I'm interested in scaling best practices, development productivity, and continuous deployment. So if you work in any of those three areas and you want to discuss things, I will be happy to do that. Really looking forward to talking to you. Okay, so the context. I was about to start, or my team was about to start a project where we were about to do a huge refactor of one of the applications. And that was really a huge refactor because we were making a monolithic application, something that users used to download and install into cloud-based solution, software as a service. So huge refactor. And I was thinking, the first thing that come to my mind is how good our safety net is for that application. Are we able to assure that while we will be doing the refactoring, we will have tests in place that will catch any potential regressions? So you know that there is this testing pyramid, and unfortunately, I need to show you this message because I'm really proud how good test pyramid we have, and this is because. In our company, in the whole organization, we work together as quality engineers with developers, teach them how to test, how to write automated tests, how to explore software, so we don't have a problem with not being able to keep up with development in writing automated tests, because automated tests are basically written by developers or implemented by developers as they are implementing changes. So we see the increase of automation as we see increase of features in our applications. So we have quite good test pyramid, on the bottom, of course, you have those unit tests, and there are plenty of unit tests for the application that we are about to change. We have some integration tests, we have WebDriver tests, and we also have those high-level system of systems types of tests. So everything is automated. We have plenty of those tests. So you may ask, what's the problem? Why you are even looking for problems here? Clearly you have the best pyramid that you could have. You have plenty of automated tests. They are definitely going to catch all the regressions that they are, and they are going to be. Yeah. So before I jump into what I found is let's talk a bit about what the presentation is going to be about. It's going to be about risk. So I'm going to talk a lot about risk. This is in the topic, right? It's going to be about tests, and basically about tests that you don't need and you need to have, and tests that you may have but you don't necessarily need to have. There are some tests in your code base that you probably don't need to even bother running. What this presentation is not going to be about, code coverage. So the other part of the topic is code coverage. Unfortunately, I'm not going to, or maybe fortunately, I'm not going to run into what code coverage is, what types of code coverage there are, what kind of tools you have, etc., etc. So if you are new to code coverage, you are not going to learn basics from me. I'm going to present you one way of measuring code coverage. I'm going to present you one tool that allows you to do that, but you will need to do investigation in the code coverage thing yourself. I'm going to talk about why code coverage doesn't work, and what we can do as quality engineers to improve standard or default code coverage reports. Okay, so how does the standard code coverage report look like? Or rather, the code coverage that is lacking information that you can act on. So maybe you have seen something like that. This is one of the reports available from a tool called Clover. And I'm showing it because it was developed by Atlassian. And also showing it because it's free now. So it used to be an application that you need to pay for. Now it's open source, so you can download the source code. You can also install it locally, and you can run the analysis against your code base to understand what are the numbers. Like this is probably the most important number here. Like what is the percentage of code coverage, right? And you can now say, yeah, but code coverage doesn't matter because we know that 100% code coverage still may cause, like code with 100% of code coverage still may be buggy, right? You still may introduce bugs that will not be cut by those tests that you have. Probably because like you have bad assertions or something like that, right? So I'm not also going to discuss that, why code coverage is bad and why you shouldn't rely only on this metric. Let's assume that we have proper quality automated tests with proper assertions, and also like we are testing different types of data, different type of inputs, so we don't really have a problem with this number showing something that isn't true. Okay, the other quite good thing about this report is that you can dive into details. Like you can analyze every single class or every single method in your code base, assuming that you work on Java or on Groovy, and understand how many tests went through a particular line in that class, particular line in a method. And this was quite important for my research. And not only you can get like all the unit tests that cover a particular unit, but also you can get information of all the other tests that you run in your CI against your code base. And those tests might be run from another JVM, so basically like WebDriver tests or like some kind of REST API integration level tests. You can always also use Clover in a way that it will show those tests in the report. So this is kind of nice to have, because based on the information that is in the standard report, I was able to fetch the data, like look into what is in the report and put the data into database. And I had to do that because we have so many tests and we have so large code base that Clover couldn't really generate those beautiful HTML reports. So instead of generating a single HTML report, I had to like generate multiple HTML reports for multiple types of tests and push the data that was in those different reports into a single database. And this is the database that I ended up with. So I know what were the classes that were covered by tests. I know what methods were covered, which numbers in those methods were covered by tests. I also knew what were like the meta information of tests that were covering those production lines, like the type of test and the test class or suite and the test case. So that was the database that I had, that I was working on to understand how good the tests are really. Okay, so let's say that you have that database and you know that the statement coverage based on the data that you have is between 80 to 99%, right? And we know that those tests are good, like they have proper assertions, they test different inputs, etc. So the question now is it enough? Is it enough to spot regressions as you will be refactoring application? So that was the question that I was trying to answer, like, and that was the question that drive me into this research. So first thing that I was able to look into is spot some low-hanging fruits, right? So the first low-hanging fruit that you can look for is maybe there is a part of code base that doesn't have that many tests comparing to other parts of the code base, right? So let's say that you have a package in your Java application that is missing tests more than any other package in the application. And maybe we should invest our time into implementing tests in that package that is lacking. Yeah. So what you are seeing here is the code base that we were working on as a visualization. So this big square is the whole code base, like the whole application, and every single rectangle that you have in that square is a package. So you see that we have plenty of packages, like more than 200 Java packages in our code base. And the size of each package represents how many tests this package is missing, right? So what is the percentage of missed code coverage? And like you can compare sizes of different packages, like compare neighbors, right? And probably what I was looking for is a package that is greater in size, like the greatest in size in this square, right? And it seems like all those packages are very similar in size. So it means that all those packages in the application are more or less lacking the same percentage of code covered with tests. So there aren't any low-hanging fruit. You can't really point based on the data to any package and say we need to implement tests here because we are lacking tests here comparing to other places in the code base. And one more thing that I need to tackle. Like the easiest option would be to implement tests everywhere we need them, right? We know that like there is like this 20% of code not covered with tests, right? But we don't have time to do to implement tests for everything for every single place where we don't have tests. So we need to optimize, and we need to look into places where, given the time that we have, we can make a change. So this is where the risk-based code coverage comes in. So let's look at the code coverage information from different point, like not from the package point, but from the lines of code. And the initial question was, is 80 to 99% of code coverage good or not? So you could say that 80% is good, right? Because like it's plenty. But if you look at it from the lines of code perspective, and let's say that you have 500,000 of lines of code in your application, yeah, it means that like 400,000 lines of code are covered with tests. But on the other hand, it also means that there is 100,000 lines of code that are missing tests. And the question now is how crucial those lines of codes are, how risky they are. Yeah. So yeah, you probably all know what risk is, right? Because like you are quality engineers, so on your daily basis, you need to drive your decisions based on risk. Like you are testing particular area of application instead of another, because you know that this part of application is risky comparing to the other. But to those who don't work on risk on daily basis, let's say that risk is just a probability times severity, right? Or in other words, frequency of something unfortunate happening times lost value when that unfortunate thing happens. So let's look at risk from the first part of the equation, right? So from probability. How likely it is that something will fail? How likely it is that we will introduce a bug to a line of code that isn't covered with tests? I'm fortunate to work in an organization that really cares about putting descriptive comments into commit changes, into commits, right? So as you can see, like we follow a pattern of commit messages. So every single commit message starts with Jira ticket, right? Like we internally use Jira, we dogfood our software, and every time something is changed in the code base, we first put the Jira ticket that the change relates to. So this allows me to look for that ticket in Jira instance, right? Like first I need to identify Jira instance where this ticket lives, because we have plenty of Jira instances that we usually use. There are teams that have their own instances. And once you know where the Jira is, you can find the ticket. And once you know what's the ticket, once you found the ticket, you can understand what's the intent of this ticket. Is it a user story? Are we adding new feature with this change? Or are we addressing a bug? So we can calculate number of bugs per days, right? We can I analyze like last 3 to 6 months of development to understand how many bugs are introduced into every single file in our code base. And I was able to get the number of bugs per number of days. But bugs are not equal, and we all know about that. Like there are bugs that come from development, and there are bugs that come from customers, right? So if you find a bug during development, I mean it's still bad, like it shouldn't happen, but it would be way worse if that bug was found by customer and reported by customer. So I did a classification of bugs, like tried to give some kind of score to every single bug that I was able to find. And clearly, like the bug that was found in development process didn't have that much points as bug found by customers and reported by customers. So based on that, I calculated number of bug points per number of days, right? So I now knew how many bug points are introduced every single day for the last 30, 60 or whatever days. And this is what I got. So you have commit frequency on your left, right? So this basically shows you how often we commit into our code base. And once again, like the square is the whole code base, the whole application. Every single rectangle is a package, right? So you see that there are packages where we commit more frequently than to any other packages. And like clearly, like there is this ping package. So we are definitely committing there more. And on your right side, you see the bug score. So how often we basically commit fixes for bugs, and also like how severe those bugs are. So you also see here that there is this ping package, right? So you may think that there is like linear correlation between how often we commit and how many bugs we have, or how severe bugs we have, right? But that's not the case. So if you calculate something like this, like bug probability, so the bug score times commit frequency, you will get different image. This ping package is no longer there because we are committing to it very frequently, and we are also introducing bugs there. But still, there are packages where we commit not that frequently, but we introduce a lot of bugs when we commit, right? So you, for instance, you have this blue package here, which is taking more size than any other, more space than any other package in our code base. And this basically means that if a developer commits to that blue package, there is higher chance that the change or the commit is bug, right? So as QA, I'm probably more interested into investing time in implementing tests for that blue package rather than any other package in our code base, because this is the most risky. Changes in that blue package are more riskier than any other changes when it comes to probability. Okay, but I said that risk is just like two-factor equation, so we also need to consider severity. So let's look at severity, or at lost value, from two perspectives, like the T-shirt perspective, which is basically developer, and business perspective, so the users or user representatives like product managers, right? So what developers care about, like what's the value to them? Like this is a very basic example, like you have a class, this class has a method, and you have another class that depends on the previous class, right? So you can say that for development and for developers, the most valuable parts of the code are the parts of the code that are references the most, right? So if you have code that everyone depends on, that code is probably more valuable than any other code that isn't that popular in the code base, right? And you can very simply find like how popular code is. Like you can just look for references in your IntelliJ or whatever, and this will give you like the number of usages. So I did something like that. I tried to analyze how different packages, like how popular different packages are. And as you can see, like there are clear winners here. Like this green package is referenced, or the code in the green package is referenced more than code in any other package. So if anything breaks in the code in green package, like probably this will affect 30% of code base, right? So we don't want this code in green package to fail, right? Because this will have a big impact. On the other hand, looking from the business perspective, what the business cares about, and when I'm talking business, I'm not really meaning like product managers or anything like that. I'm talking about us, because we are business, like we are developing value. So there are two sides of us, right? Engineering side and the business side. So I'm talking about like business about the other side. So we care about our users, right? We care about code, and we also care about our users. So what our users care about? Like we are giving them tools, like a set of tools that they can use while they work with our application. So those are called, let's call them features, right? So we have users who use our features, and based on the usage, we can determine which features are most popular, which are most critical for our users, right? And of course, you can look at popularity of a feature from like different perspectives, like how frequently it's used and how many unique users it has, right? So I'm going to make like a very big simplification here. Let's say that a feature in application is a resource that we are giving to users, right? Like this is a REST API resource or a page. So you definitely like you have access to like access logs, right? So you know how often a particular REST API resource or how often a particular page is being requested, by whom, by what customer, but what user, etc. And if you have access to that information, you can create something like that. Like you can understand how particular resources are, like how popular they are, looking at the number of requests and looking at the number of unique users, right? So like you see that there is a difference, right? Like looking from the number of requests, this brown feature or the brown resource is most popular. But if you like use different metric, like use the unique users, the violet feature clearly wins, and the brown feature is somewhere like hidden. So yeah, you need to decide like what you are going to use, like what kind of metrics for your prioritization. I decided to look into like the number of unique users. So that's why I don't want a bug end up here affecting this violet feature. Okay, but how to translate those features or those resources into code, right? Because we know what code or what lines of code are covered with tests and what are not, but we don't know what features are covered with tests and which are not. So because I made this simplification that a feature is just a resource, in your code base, every resource needs to be handled somehow, right? So if it's REST API resource, you probably see something like that, right? If you work with Java application. So you have some part of your code that is responsible for handling a request, right? Of course, in reality, this is not that simple, because you have those basic handlers, but those basic handlers will delegate work to some classes. Those classes will ask other classes, etc., and you will have like a chain of communication going on in order to produce a response. And it's true also for our application. And but you still can visualize and can understand what is involved in handling every single resource. What is involved? What parts of your code are responsible for every single feature in your application? And this is just an example of what I did. at the top of the tree, you have like this method that is responsible for handling a request. And as you can see, you have multiple levels of calls, right? Like in the first level, this method is probably the handling method is calling some classes, some objects. Those classes are calling other classes, etc., etc., etc. And you have like multiple level structure here. The fun is that now, when you have the whole tree, you also have information what is the code coverage for every single node in that tree. So you can combine that information to understand what is the code coverage of a feature. Okay, and also you can understand like how many users depend on your code base, right? Because you can translate feature into code. And this is what how the data looks like visualized. So this is the number of dependent unique users on a feature, right? Looking from the code base perspective. So you see that there are packages that have more dependent users, unique users that depend on the code in those packages that any other packages. So that means that if anything breaks in this green package, so if your developer is working on changing a class, and this class is in a green package, and for some reason bug is introduced, this bug will affect more users than any other bug introduced in any other packages. So I really care about like having good coverage here in this package. Okay. So now let's move into some statistics and mathematics. Okay, because like we started with risk, right? And now we have those two parts that are needed. Like we have the probability part and we have the value or severity part. So you can do some basic mathematics. Like you can combine those two factors to calculate risk. You can even like expand the equation to introduce some weights, etc. Like we care more about users than we care about developers and so on. And we want to reflect that in our risk equation. And once you do the calculation, once you combine all the data that you have into a single number, this is how risk look like in our application. Like still, you have the big square is the code base. Every single rectangle is a package. And as you can see, we have back this pink package here, but we also have like this little brownish package that is the most risky package in our application. This means that if a bug is introduced here, it will either, either it means that it's more likely to introduce a bug, or it means that more users will be affected by bugs. In general, it means that the risk is higher for bug being introduced here. So we care about covering more classes with tests in this package. Okay, but you can like this is something that got to me. Like if you want to look at coverage from risk perspective, so coverage as a function of risk, you can say that if risk is going into 1, right? So it's like 100%, you are 100% sure that something will break. You want the code coverage to be 1, right? You want everything to be covered. But on the same side, like if risk is equal to 0, like let's say that you are not changing anything, right? You are not changing parts of code base. You want the coverage to be 0, right? You don't care about running tests in parts of code that weren't changed. So this is my test coverage efficiency metric. And I looked into how does the test coverage in the application, in my application looks like, looking from the risk perspective. Like, do we have higher percentage of code covered that is more risky, most risky, and do we have a lower percentage of code covered that isn't that risky, right? And it seems like that was the case, because as the risk increases, so does the coverage. Okay, so now back to the original question. Is 80 to 99% of code coverage good enough? And I still don't know what the answer is, but I can rephrase the question. And in order to do that, I need to dive into statistics, If you are aware what percentiles are, you probably will be familiar with the graph. If you are not, let's say that you can divide everything into buckets, and let's say that you have hundreds of such buckets, and as you move from 0 to 100 buckets, and let's say that you want to understand, like some kind of metric will increase for you, right? Like, so let's say that you have 100 buckets of risk, and you want only to focus on the most risky buckets. So this is where percentiles come in. You want to focus on the 95 percentile, so the most 5 risky buckets. So I looked into like the 95 percentile of risk and come up with questions from the original problem, right? And 80 to 99 coverage. So are there high risk methods with 0 statement coverage? So do we have methods that are in the 95 percentile of risk that do not have any tests? And with the data that I gathered, I found out that there are like 10 methods like that. Are there high-risk methods without 100% statement coverage? So we have some tests, but we still don't have like 100% of code covered here. And there were like 50 methods that were in this percentile. Are there high-risk methods without at least one integration test? Because we want to have as many unit tests as possible, but we are also aware that unit testing and mocking is introducing a risk that the test won't reflect reality. And there were around 200 methods that were missing integration test. So, what I want to take from my journey, like, it would be nice if you could do the same analysis and to understand how well your code is covered. Do you cover the most risky parts of your application? And probably you will encounter that code, like code that isn't referenced by anything, right? Other perhaps than tests. So why you even have such code? Maybe you can simply delete it. Maybe you will encounter dead features, so resources that are not used by anyone. So why maintaining them? You probably have also tests for them that you bother running and wasting your time on executing them. And probably because all of that, you probably have dead tests. So tests that cover code that is either not used or does not provide any value to users. You can also improve test execution with the data. Like even if you just do the first part and do the code coverage thing and create a database that will have tests and production code that is covered with tests, you can decide which test to run on which change. And also you will have a good data set to look into how good your tests are. Okay, test coverage alone isn't very useful, like that's clear. Just having a number like 79% doesn't tell you much. It doesn't tell you is it good, is it not. So you need to do a bit more to understand if something needs to improve. You don't have time to improve everything, so you won't have time to add all the tests, and you cannot expect anyone to do that for you. As I said, developers write tests for the application that I work on. So I can't really go to them and say, let's spend next 20 sprints to implement missing unit tests. It's not how it works. But you can drive decisions what need to be implemented by risk analysis, and by looking at the historical data, how often bugs are introduced, and looking at the value, right? Like how crucial to developers and how crucial to users given code that is missing unit tests or any other tests is. Less coverage may not be a problem. If your code is not changed frequently or it doesn't bring that much value, I mean, don't invest time into writing unit tests or any other automated tests for that code. In fact, in some cases, less coverage might be good, right? Because you need to run your tests, and we are running tests on every single change. And if you have a suite of 100,000 tests, and you run those tests every time something changes, like it costs a lot of time for development. So we want to be smart about what we need to run. And having information about having this database of code coverage helps make this decision. We want to run this thing and not the other. Yeah, and I urge you to analyze impact of your tests. Like do the code coverage thing, get the data from reports, put them in some kind of database, and every time your code is changed, look into what tests need to be run and what can be skipped, right? And just run the tests that you need to run. But I can tell you like how to do that and how we did that. Unfortunately, I don't have time. So hopefully organizers will invite me next year, and I will have time to discuss the test impact analysis next year. So thank you.